right, welcome back. Ooh. Any questions before we get started?
Sir.
Cool. All right. Well, we're covering 9.5 today, the shortcut to the derivative. So let's just wait for everybody to join. Couple of minutes. Here we go. What is this? Business Cal. And then
I'm actually going to try to do it.
9.5. There we go. Okay. In the chat are the notes we're covering today. So download them, follow along. All right, let's do this. Okay. So on Wednesday, we learned about the definition of the derivative, and it was really, really long. Well, today is more rewarding because we get the shortcut to the derivative. So these are differentiation properties. Okay. So the derivative, the notation, we've already seen one of the notations already, is f prime of x. This just means the derivative. Another notation could be y prime, and another notation could be dy over dx. All this says is take the derivative. So it's the derivative of y with respect to x. That's all that is. Okay. And this notation, we'll see more of it after the third test, I think. But yeah. So mainly you'll probably just see these two notations a lot. But if you see this one, again, don't be scared. All it means is take the derivative. Okay. So the first rule for derivatives is the constant rule function or constant function rule. So if y or f of x equals some constant c, then the derivative of any constant is going to be 0. So this means f prime of x would be 0, y prime would be 0, or dy over dx would be 0. So the derivative of any constant is 0. And remember, a constant is just a number by itself. So if I said y equals 10, the derivative of 10 would be 0. And I like to put a diagram to everything I'm talking about. So remember that derivative means slope. So y equals 10 would be a horizontal line. And it just so happens that the slope of a horizontal line happens to be 0. So this slope would be 0. So remember, whenever you're finding the derivative, you are finding the slope of that original function. So if our function's y equals 10, the derivative of that would be 0. Or we could say the slope of that function would be 0. So that's pretty neat. Okay. Now we get to our examples, and here it is, example A. If f of x is 3, what is the derivative going to be?
0.
0, that's it. Easy enough. Next, if y equals -5, what is the derivative of -5 going to be?
0.
0. Oh, too easy, right? So the derivative of any constant is 0. Everybody good with that? Okay. Next is the power rule. So this is one of the most important rules for derivatives. So what this rule states is if f of x or y equals some power function, x to the nth power, where the exponent is a real number, then the derivative is given by n times x to the n minus 1. So all this means by the power rule is we take, so if I rewrote it up here, if f of x was equal to x to the n, this exponent comes down, which you see right here, n times x. And then the next thing you would do is subtract 1 from that original exponent. So your derivative is given by n times x to the n minus 1. That's it. The power rule will be your best friend. So let's go ahead and try it out. So for these examples, we just want to find the derivative using the power rule. So for number 1, or for A, we're going to say the derivative f prime of x, well, just like using the power rule, the power of 5 will come down. So this power of 5 will come down, and you'll get 5x, and then the new exponent will be the original exponent minus 1. So our derivative is going to be 5x to the 4th. That's it. Calculus is too easy now, guys. Now imagine going the old school way that we learned on Wednesday. You would have to plug in x plus h, and you'd have x plus h to the 5th power. I mean, to the 5th power. Oh, I wrote everything backwards. You'd have x plus h to the 5th power. There we go. And you would have to expand that 5 times. You would have to distribute and distribute and distribute. And an hour later or 2 days later, you would arrive at this answer. So what we have just done is made derivatives really, really easy by the power rule. Okay. So let's try it again. Let's see if you got it. Here, y equals x to the 30th. So I'm going to say the derivative y prime. And what's my derivative going to be?
30x to the 29th.
That's it. Now imagine putting x plus h into that one. You'd have to distribute that 30 times. No thank you, right?
Ain't got time for that.
Nobody's got time for that. All right, let's keep going. So C, the derivative of y equals t to the negative 3. I'll just say y prime again. And what's my derivative going to be here?
Negative 3t.
Negative 3t to the negative
2.
Careful.
Well,
When you subtract 1, you go more negative.
facts.
So negative 3t to the negative what?
4.
4. There we go. So watch your negatives, right? Okay, so this answer is perfect, but my math lab may have you rewrite it as a fraction. So just a quick refresher. If you're ever given x to the negative n, you can rewrite it as 1 over x to the n. So if my math lab doesn't take this answer because it's picky, then your answer may be negative 3 over t to the 4th. I'll put MML. All right. So any questions on that? Hopefully it takes the first one, but rewriting it the next way is actually good practice because given some of these derivatives, we're going to have to rewrite them a certain way. Okay, so there's C, and now D. This notation, d over dx, this just says take the derivative of x to the 5/3. That's all this says. D over dx is just the derivative with respect to x. So we take this derivative, and the 5/3 comes down, and now you have to subtract 1 from the original exponent. So remember, do a little fraction work, right? 5/3, oh, can't write. 5/3 minus 1, well, to subtract those, you have to change 1 into a fraction and get a common denominator of 3, which means you'll get 5/3 minus 3/3, which will give us our new exponent of 2/3. That's it. All right. Everybody good with that? Okay. Let's keep going. All right. So now we're given f of x equals 1 over x to the 4th. We can't take the derivative in this form, so we have to rewrite it algebraically in order to take the derivative of it. And what we're going to do again is introduce this algebraic rule again. So remember, now, if you have 1 over x to the nth, you can rewrite it as x to the negative n. And this is what we're going to have to do in order to use the power rule for the derivative. So first, I'm just going to rewrite the function below. We have f of x equals 1 over x to the 4th. And if I use this algebraic property, I get f of x equals x to the negative 4, which means it is now in the form that's ready to go when we apply the power rule. So this means we can use the derivative now. And what is the derivative of x to the negative 4 going to be?
-5.
Well, what number is coming down?
Negative 4x to the power of -5.
There you go. Negative 4x to the negative 5th. Don't forget to bring the power down, right? And subtract 1. So once again, this answer is just perfect as it is. But if you have to rewrite it, you'd rewrite it as negative 4 over x to the 5th. Any questions on that one? So you see how we're introducing these algebraic properties, because remember, calculus is very heavily algebra based. So we need to do these properties, use these properties in order to rewrite the function in order for us to take the derivative, which for f is another example. So y equals the square root of u. Again, we can't take the derivative in this form, so we have to figure a way to rewrite it. And since this is the square root, we're going to have to use another property that takes a radical and rewrites it as a rational exponent. So that property is the square root of, actually, let me say this. The nth root of x, there we go. The nth root of x can be rewritten as x to the 1 over n. So there's another algebraic property. This takes a radical and rewrites it as a rational exponent. Okay, which means down below, I'm going to do the rewrite. I'll have y equals And since this is the square root, there's a 2 here. But I mean, we never have to put it there because this is understood to be the square root. But I'm going to write it there so you understand the conversion. The square root of u is going to be rewritten as u to the 1/2. All right. And now this is in the proper form for us to apply the derivative, the power rule derivative. Which means down below, I'll say y prime, and the derivative, you're going to have 1/2 u. And remember to subtract 1. So what's 1/2 minus 1? Or what's 50 cents minus $1?
-1/2.
-1/2. There you go. Yeehaw. And this is a good answer. But again, if you have to rewrite it, then this is how you would rewrite it. You would get 1 over 2u to the 1/2. There we go. All right. There could be one more rewrite if it was being really picky. You can just go ahead and rewrite it as 1 over 2 square root u if it wanted to be that picky. I don't think so, though. Okay. Any questions on that one?
All the rewrites use
Mhm.
that same x to the negative n equals 1 over the n.
Exactly.
Cool. Got it. Thank you.
Yep. Okay. So just like the 2 above, the next one, we have to rewrite this as well. So we're given the derivative. This says take the derivative of 1 over the square root of x with respect to x. So we have to rewrite 1 over the square root of x using the properties we have just introduced, the algebraic properties. So this is going to become d over dx of, and my first rewrite is changing this square root of x into an exponent. So I'm going to get 1 over x to the 1/2. So we have just rewritten from radical to exponent. And now we still can't take the derivative in this form. So my next rewrite is going to use the negative exponent property. If I have 1 over x to the 1/2 and I rewrite this, I'm going to get x to the negative 1/2. And now we have put it in the proper form so we can take the derivative. So let's go ahead and do that. I'll write this down below. D over dx of x to the negative 1/2. We take the derivative, and that negative 1/2 is coming down. And you'll have negative 1/2 x to what new power?
-3 over 2.
There you go. Negative 3 over 2. Now, like I said, this is a great answer. But if it makes you rewrite, then you are going to have negative 1 over 2x to the positive 3/2. There it is. Okay. Any questions on that one? All right. Let's keep moving then. All right. So next property is the constant multiple property. This says if you have some constant times a function, k times u of x, then when you take the derivative, all it says is take the derivative of the function and leave the constant alone. So here again, you have k times u prime of x. So all this wants you to do is take the derivative of the function, and then you'll multiply that constant back in, giving you k times the derivative of that function. That's all it says. So let's go ahead and try this out. So for a, f of x equals 3x squared. So I'm just going to box this function, x squared, and that's all we want to take the derivative of. So when I say the derivative, f prime of x, that 3 is coming down, and now we are going to multiply it by the derivative of x squared. What is the derivative of x squared?
2x.
Good. Just 2x, right? Because if you use the power rule on it, you'll get 2x to the first. Do we need that one there?
No.
No. So you'll get 2x, and our final answer is 6x. There you go. Now, one way you could think of these, if you don't like separating the terms, is, well, just look at the original problem and just say, hey, this 2, when you apply power rule, this 2 comes down, multiplies the 3, and gives me 6. But the constant rule is there, the constant multiple rule is there to let you know that, hey, ignore that coefficient or ignore that constant, take the derivative of the function, and you can bring the constant back in. So it's however you want to treat it. Okay. And now for B, same thing. Let's go ahead and practice the constant multiple rule above. And I'm just going to rewrite this. So for t cubed over 6, I am going to take out the fraction of 1/6. And what that leaves me with is the function t cubed. Because 1/6 times t cubed is still t cubed over 6. But I'm only rewriting this so you see how this constant multiple property works. Which means all you have to worry about now is the derivative of the function inside, t cubed. So we'll say y prime equal to the 1/6 stays out front. And what's the derivative of t cubed?
3t or 3t squared.
There you go. 3t squared. There's our derivative. 3t squared. And then we just multiply this 1/6 back in, which means we'll get 3 over 6t squared, which is just 1/2 t squared. All right. Perfect. Okay. Any questions on that one? All right. So next one, of course, we're going to have to rewrite this one as well. Y equals 1/2 x to the 4th. So we have to do a bunch of rewriting in order to take the derivative. So when I rewrite this, the first thing I'm going to do is take the fraction out. I'm going to take out 1/2. And what this is going to leave me with is 1 over x to the 4th, which now we get to rewrite by using the negative reciprocal rule, the negative exponent rule that we saw earlier today. So if I rewrite this, I get 1/2 x to the negative 4, which means we are now in the proper form to use the power rule derivative. So let's go ahead and do that. And we'll get y prime, that 1/2 stays out front. And now all I want is the derivative of x to the negative 4. What is that going to be?
Negative 4x, negative 5.
That's it. Negative 4x to the negative 5th, and distribute the 1/2 back in. And lucky for us, half of negative 4 is just negative 2. Okay, and once again, that is a perfect answer, but if it wants you to rewrite it, we'll rewrite it as negative 2 over x to the 5th. All those rewrites, right? Okay. Everybody good with that? All right. Okay, next property for derivatives is the sum and difference property. So this just says if you have multiple terms connected by addition and subtraction, so this says you have u of x plus or minus v of x, and then you take the derivative, well, the derivative can be applied to each term separately, to each function separately. That's all this says. So if we have more than one term, the derivative can be applied to all the terms, as we'll see down below. Okay. All right. So A, f of x equals 3x squared plus 2x. All right. So if we use that constant multiple rule, I'll just use it again. We want to know what are the derivatives of x squared and what's the derivative of x. So I'll say f prime of x, the derivative, that 3 will remain out front. And what's the derivative of x squared?
Two x.
2x, good. Plus 2 times, what is the derivative of x?
X.
It's a fun one, right? So if I said d over dx of x, right? What power is on this x that we don't show? 1, right? So now, if we follow the power rule for this, that 1 would come down, and you'd get 1 times x to the 1 minus 1, because that's the power rule, right? And then you'd get negative 1x to the 0th. And remember, anything to the 0th power, any number to the 0th power is always 1. So this just becomes 1 times 1, which is 1. So if you are told to take the derivative of x, a single variable, the derivative is always 1. And this could be said for any other single variable. If I said d over dt of t, the derivative of t would be 1. If I said d over dw of w, the derivative would still be 1. If I said d over dy of y, the derivative would still be 1. So if it's a single variable to the power of 1, the derivative will always be 1. Okay, which means back to our derivative. And the derivative of x we just saw is 1. So our final answer is 6x plus 2. Good stuff. Okay. And now let's keep going. Here we are given 4 plus 2x cubed minus 3x minus 1. Okay. So taking the derivative of this, we're going to say y prime, and I'll box these off as well, just because this is what we've been doing. And we'll start off with 4. 4 is a constant. So what is the derivative of 4 going to be?
0.
0. Good. The derivative of 4 is 0 plus 2 times, what's the derivative of x cubed? Anybody?
3x squared.
There you go. 3x squared. 3x squared minus 3 times, and what do you think the derivative of x to the negative 1 is? Negative 1x to the negative what?
Negative 2.
There you go. Yeehaw. And now let's go ahead and rewrite it. We don't need the 0 there anymore. Just distribute that 2. We'll get 6x squared, and then distribute that negative 3. Negative negative makes positive, and you'd get 6x squared plus 3x to the negative 2. Done and done. I don't think it'll ask for a rewrite on that. Okay. Any questions on that one?
So why does the 4 become a 0?
Because it's a constant. And remember the first rule for today, what is the derivative of all constants?
0.
There you go. So we're just implementing all the rules we have learned today, right? Everything's coming together, plus a little bit of algebraic rules that we need in order to take the derivative. Okay. which brings us to C. We get the cube root of W minus 3W, and we have to rewrite this because we can't take the derivative of the cube root of W in this form. So again, we rewrite it from radical to exponent. So you'll get W to the 1/3 minus 3W. So the cube root of W becomes W to the 1/3. Remember that exponent property. The nth root of x is x to the 1/n. Okay. We are now in the perfect form to take the derivative. So I'll say y prime equal to, and let's look at W to the 1/3. What's the derivative of that going to be?
One-third.
1/3 W to the what power? Because again, you'll subtract 1 and you'll do 1/1, but it has to become 3/3. So this will become 1/3 minus 3/3, which gives me negative what?
2/3.
2/3. There you go. Negative 2/3 minus 3. And what is the derivative of W all by itself?
1.
1. So this is done. Don't worry about rewriting it. Any questions on that? All right. Now we come across D. D over dx of 5/3x squared minus 2/x to the 4th plus x cubed over 9. So we have to do a lot of rewriting on this one in order to take the derivative. So let's start at 5/3x squared. So we're going to start here first. So I'm going to rewrite it. I'll say d over dx of, and for the first term, 5/3x squared. I'm going to take that fraction of 5/3 out, and that'll leave me with 1/x squared, which we'll rewrite that in a second. Okay. Minus, now we look at the second term. 2/x to the 4th. I'm going to take 2 out, and that's going to leave me with 1/x to the 4th. And then we look at the third term, x cubed over 9. I'm going to take the fraction of 1/9 out, and that leaves me with x cubed. Close parentheses. Okay. So all I've done is take out the coefficient, or we can call it the constant. And now we have one more rewrite because we can't take the derivative in these forms, 1/x squared and 1/x to the 4th. So we'll get d over dx, parentheses, 5/3 times x to the negative 2 minus 2 times x to the negative 4 plus 1/9 times x cubed. There we go. Everything is rewritten, and now we are ready for the derivative. So let's do it. 5/3 times, what is the derivative of x to the negative 2 going to be?
Negative 2x to negative 3.
There we go. minus 2 times, what's the derivative of x to the negative 4?
Negative 4x to negative 5.
There you go. Plus 1/9 times, and what is the derivative of x cubed?
Well, 3x and 2.
3x squared. There you go. Now the calculus is done. The derivative is done. The rest is cleanup. So distribute the 5/3 to the negative 2, and that'll give me negative 10/3 x to the negative 3. Distribute the negative 2, and I'll get positive 8x to the negative 5th. And distribute the 1/9, and 1/9 times 3 is 3/9, which will give me 1/3 x squared. There we go. Now, if it did ask you to rewrite this, you could have this as negative 10 over 3x cubed plus 8 over x to the 5th plus, and this would be x squared over 3. All right. Any questions on that one? So much fun, right?
Yep.
So much
right.
fun.
Always fun. Hey, this is better than the last one, right?
That is true.
Okay. So these next examples, we just want to take the derivative of the given function, but of course, we're going to have to do a lot of rewriting. Here we're given f of x equals 1 plus x squared over the x to the 4th. We don't know how to take the derivative in this form, so we're going to rewrite it algebraically so we can take the derivative. Okay. So I'll just rewrite the function here. F of x equals 1 plus x squared over x to the 4th. And now we think algebraically. How could we split these up? And we notice that how many terms are in the numerator?
2.
2. Are they over the same denominator?
Yeah.
That means we can split it into 2 separate fractions. I can rewrite this as 1 over x to the 4th plus x squared over x to the 4th. So I rewrite it as 2 separate fractions, which means now I can simplify. 1 over x to the 4th becomes x to the negative 4. Plus, I have to reduce here, x squared over x to the 4th. This is gone, and this 4 becomes a 2. Which means if I rewrite this, I'd have 1 over x squared or x to the negative 2. We have now rewritten it algebraically, which means these are in the proper form. So we're ready for the derivative now. So our derivative, f prime of x, and the derivative of x to the negative 4th. What is that?
Negative 4x to negative 5th.
There we go. And what is the derivative of x to the negative 2?
Negative 2x to the negative 3rd.
That's it. Done. Okay. Cool. So you must rewrite before you take the derivative. Any questions on that one? Okay. Again. Example 6. Find the derivative of this function, and we're going to treat it the same way as the last one. How many terms are in the numerator? 3, which means how many fractions can I split it into?
3.
3. Good. I can rewrite this as 5 over x minus 3x over x plus 4x squared over x. So we have put all 3 terms over the same denominator, and now we can simplify algebraically. So 5 over x can be rewritten as 5x to the negative 1. 3x over x, your x's will cancel. So you get minus 3. Plus 4x squared over x, this x cancels, that 2 becomes a 1. And we are left with 4x. Which means we are now ready for the derivative. So f prime of x, and first up is 5x to the negative 1. What is the derivative of 5x to the negative 1 going to be?
Negative 5x to negative 6.
Negative 5x to the, remember, you only take 1 away from the exponent that's there.
Oh,
So negative 5x to the negative 2. Good. And now, what's the derivative of negative 3?
0.
0. So I'll just say minus 0 plus, what's the derivative of 4x?
4.
Just 4. That's it. Which means our final answer is just negative 5x minus 2 plus 4. There we go. Any questions on that one? Then we made it to the last page, y'all. All right. Example 7. The total sales of a company in millions of dollars, t months from now, are given by the function S of t equals 0.05 t cubed plus 0.2 t squared plus 4t plus 6. Step A says find S prime of t. So this says find the derivative. So we'll start with that. We'll start with step A. A. S prime of t. So let's say S prime of t. And we'll look at the function above, and I'll just separate the functions. So that's 0.05. And what is the derivative of t cubed going to be?
3t squared.
3t squared plus 0.2 times t squared. What's the derivative of t squared?
2t.
2t. Good. Plus 4 times the derivative of t. What's the derivative of t?
1.
1. And plus, what is the derivative of 6?
0.
0. There we go. Now let's just clean it up. S prime of t gives me 5 cents times 3. So I tripled my 5 cents and end up with 15 cents t squared plus 0.2 times 2. I have 20 cents and I double it. 0.4 t plus 4. There's my derivative. Okay. And then I'll leave that there. I need that function there. B says find S of 2 and S prime of t. So all this wants us to do is take 2 and plug it into the original function, and then take 2 and plug it into the derivative. So that's what we're going to do there. So for B, we want to know what's S of 2 and what's S prime of 2. So let's go use a calculator. I don't have my browser open. Whatever. That I did. Desmos. And I don't need the graphing calculator. I could just use a scientific calculator. There we go. Let me get both functions up there, and here we go. I'm going to put 2 into the first function, so 0.05 times 2 cubed plus 0.2 times 2 squared plus 4 times 2 plus 6, 15.2. And now I'm going to take 2 and plug it into the derivative. So 0.15 times 2 squared plus 0.4 times 2 plus 4. And I get 5.4. Okay. So there's B. It just wanted us to plug those numbers in. Now C says plug in 13 to the original and plug in 13 to the derivative and interpret what all of it means. So C, we want S of 13 and S prime of 13. So let's go up here and say 13, 13, 13, and I get 201.65. And then here the same, 13, 13. And I get 34.55. Okay. So when using your calculator, just be careful how you're typing everything in. You're using Desmos like I am. Perfect. You get to see everything as you type it in on one line. Okay. So now I'm going to go back to the notes screen. Just making sure all my numbers are right. Good. Okay. And now we want to interpret what all of this means. So sales is represented by S, and T is in millions of, sorry. Sales is in millions of dollars represented by S, and T is the amount of months. So this says for our first answer, this says that after 13 months, we will have made how many millions of dollars?
201.65.
That's it. Sales are 201.65 million. Okay. And then S prime of 13. So remember that the derivative means slope. So whatever answer you come out with here will tell you whether our slope is increasing or decreasing. So is this 34.55 a positive number?
Yeah.
So in terms of the derivative, we must say that at 13 months, since that's a positive number, sales are what?
Increase.
Sales are increasing by how many millions of dollars?
34.55.
There you go. Because remember, the derivative finds its slope at exactly 1 point. So what we're saying is that at 13 months, when t is 13, the slope at that exact point is 34.55 million. So this company's sales are that great that at 13 months, their sales are increasing by 34.55 million. Now that must be nice. And that's it, y'all. Those are the shortcut derivatives. Now, was that better than the last one?
Yes, sir.
By a lot, yes.
For sure, right? Okay, then we are done.